Okay, coming to the remaining properties, that is ninth one, it is time convolution property. This is also very much useful because you are going to use only multiplication in case of frequency domain, similar to the Fourier transform. So the Laplace transform of convolution of two signals is nothing but just multiplication in Laplace domain, that is x1 of s into x2 of s. And where what is this convolution? Basically the convolution is, or it will be given by integral 0 to t x1 of t minus tau into x2 of tau d tau. Okay, that x1 and x2 can be interchanged, you will get the same answer. Okay, then multiplication over or modulation over or convolution in s domain. For convolution in s domain, that is x1 of s convolved with x2 of s divided by 2 pi I or 2 pi j will be, actually it is the Laplace transform of x1 of t into x2 of t. Okay, then conjugation properties are saying that x conjugation of t Laplace transform will be x conjugation of s conjugate, x conjugate of s conjugate. Remember, where x of s is x conjugate of s conjugate is nothing but x of s. We check this once. Okay, right. So here also, similar to Fourier transforms and Fourier series, there will be Parseval's relation, that is integral minus infinity to infinity x1 of t x2 star of t dt will be given as 1 by 2 pi j integral sigma equals to j infinity to sigma plus j infinity, sorry, minus j infinity to plus j infinity is nothing but integral of x1 of s x2 star of minus s star. This is important, right? And ds, integral over ds, and it is only for complex x1 of t and x2 of t. Then the most important types are initial value theorems, final value theorems, right? So this is initial value theorem. That means, as I have discussed in the control systems, x of 0 will be given by limit s tends to infinity s into x of s. It is nothing but x of 0, so limit t tends to 0 x of t also, that is. And final value theorem, x of infinity is limit t tends to infinity x of t equals to limit s tends to 0 s into x of s. Okay, and you need to check some conditions before applying this initial value and final value theorem, that I have discussed nicely in our control systems lecture, so you go through that. Then time periodicity property. So the Laplace transform of periodic functions, this is also one of the important concept because it is having some different formula, like, so x of t equals to x of t plus nt here for a periodic function, that is for all t greater than 0, where capital T is the period of the function and n is 0, 1, 2 and so on. Then what will be the Laplace transform of that periodic function? It will be x of s equals to 1 divided by 1 minus e power minus st. This is important coefficient, that is 1 divided by 1 minus e power minus st into x1 of s. What is this x1 of s? x1 of s is nothing but the integral from 0 to capital T, that is important, not 0 to infinity, which is there for a generalized Laplace transform of a function, but here for a periodic function you need to integrate from 0 to capital T into x of t e power minus st dt. That is the Laplace transform definition only, but integral limits are varying. Right. Thank you.